All right, so solving systems by graphing, what's going to be happening is they're going to be asking us to find solutions to two systems, okay? So two equations. So they're going to give you two equations and they're going to ask you, do they cross each other? Are they parallel? Or are they the same line? Like, what are they? And if they do cross each other, can you tell us where it happened? So that's what it means by solving the system of equations is can you tell us whether or not they have one solution, no solution, or infinitely many solutions, okay? So I'm going to write that down really quick because these are questions they're asking you in the homework. So a system of equations can have one solution, no solutions, or infinitely many solutions. And right now I'm going to describe how you get each one of these, okay? But a system of equations, if they give you two equations, they say, hey, do these have an answer? You're either going to say yes, one, no, none, or yes, infinitely many. Okay, and how can you tell the difference? So right now we'll talk about that. But again, there's a question on your homework that says, how many solutions can a linear system of equations have? Well, there you go. There's your answer. A system of equations can have one, no or none, and then infinitely many. Okay? So let's talk about each one of these. So it can have one solution. All right? If it has one solution, the lines cross each other at a point. So notice these lines cannot be parallel, right? If the lines are parallel, they're not going to cross each other. So if it's going to have one solution, the lines have to cross each other at some point. So they will not have the same slope. If they have the same slope, then we say that they're parallel. And if they're parallel, that's a different situation. We'll talk about that next. Okay? But one solution, that means the lines cross each other at a point. I'm going to put a little parenthesis here. Slopes not equal. Okay? Their slopes are not the same. All right, second one. No solution. Okay? So it'll have no solution if the lines are parallel. Whoops. The lines are parallel. Okay, which means that their slope are the same. Okay, their slopes are the same. So if you can tell that the two lines have the same slope, automatically say no solutions. Okay? If the slopes look different, then you say one solution. Okay? So then how do we find infinitely many solutions? We normally abbreviate that IMS. Okay, now I'll write that right now. But infinitely many solutions. Okay, the lines, or let me put it right here in green. IMS. So that's an easy way to write infinitely many solutions. Okay, IMS. So the lines are exactly the same. Okay? The lines are equal. They may not look like, but once you start solving for y, you notice, wait a minute, this line and the other line have the exact same slope, the exact same y-intercept, everything's identical. That means that these two lines are the same. And if the two lines are the same, they have infinitely many solutions. Okay? Now, why is that the case? Well, let's think about it. If lines have solutions, so I'm just drawing just some random lines here, okay? So if you have lines that cross each other, then their solution is right there, right where they touch. Okay? That would be an example of a one solution problem. Okay? Two lines crossed each other. Okay? Now an example of a no solution would look like this. If they have the same slope, then they're never going to cross. So that's no solution. Okay, this is why you guys got to make sure you know how to graph, because there's going to be some problems here where they're just going to tell you, look at the equations. Can you tell us by solving whether there's one, none, or infinitely many? And then they're going to say, okay, now graph. Can you graph them and tell us if it has one, none, or many? So if your graph looks like the first set where they're crossing each other, then they have one solution. If it looks like the second set where they're actually not touching at all, then you say there's no solution. Okay, so I'll put that right here. This would be one, none, or no. Okay, and then the other situation is this one. If I graph a line, and then I recognize that the next line is identical, same exact line. So if I zoom in just to kind of show you, they're identical lines. Well, how many times do those lines intersect if they're laying right on top of each other? Infinitely many, right? They're literally touching each other at every single point, right? So if they're the same line, then they're going to touch every point on that line, okay, if it's right on top of each other. That's why we say that these have infinitely many solutions, okay? Because the same line is on top of itself. So this would be IMS, okay? Infinitely many solutions. So a line on top of itself. Now, just so you know, this is all intro, everything we've done, right? We talked about, how many solutions can a system of equations have? We say one, none, or infinitely many. I described to you guys the situations in which each one can occur. So one solution occurs when a line crosses another line at one point. Then you just got to tell me what that point is. It has no solutions if the lines are parallel. And then you have infinitely many solutions if the lines are exactly the same. Okay? So if they're exactly the same, IMS. All right? So let me go over some examples with you guys. So example number 1. All right. So they're going to say, how many solutions does it have? Okay, so how many solutions do these have? Now, the instructions in your homework says, does each system have one, none, or infinitely many solutions? So I'm just rewriting the question. How many solutions? So here's the first one. Y equal 3 over 2x minus 1, and y equal negative half x plus 3. So this is how I do these problems, okay? I go easier to harder, okay? So first thing I ask myself is, are these lines parallel? What do you guys think? Parallel? Why not? They don't have the same slope, right? The top equation has a slope of 3 over 2. The bottom equation has a slope of negative 1 over 2. So that means these cannot be parallel. So if they're not parallel, let me kind of do this really quick. I'm going to put 1, none, or IMS, okay? So since they're not parallel, it's not none. Okay? Next, I'm going to go and check to see if they have infinitely many solutions. Are these equations the exact same equations? No, I mean, you can tell, right? They're not the same. So it's not IMS. So therefore your answer is one solution. Now, if you wanted to check that, this is why they said in the very top, use Desmos as needed, because you can graph this with Desmos just to check, okay, and see what happens. Okay, you can check and see what happens. All right, if you see them crossing at one point, they look kind of like an X, then yeah, one solution because they crossed at one point. All right, now, just, you guys don't have to do this if you don't want to, okay? I kind of want to go a little fast through this part because, again, you can use Desmos, so you don't need to draw this at all. But let me just show you a really quick look at what these equations look like. And again, you don't have to draw it. Just look, okay? You can always use Desmos to do yours. So the first one, 3 halves x minus 1, starts at negative 1, 3 up, 2 over, right here. So this line is right there. The other line, negative half x plus 3, started at positive 3, 1 down, 2 over, crosses there. You see this right here? That's my solution. The solution would be that point, which is 2, 2. That's my answer. 2, 2. That's my solution. Okay? So you can do this yourself, graph it on your own, or you can use Desmos if you want. They're not asking you to graph these, but if you want to double check, you can use Desmos or you can graph it yourself, up to you. But I just wanted to prove to you guys that it's 1. So why would you graph it instead of doing what I did? Well, you would graph it so that you didn't have to ask yourself all those questions. Do they have the same slope? No, they don't. So then it's not a no solution type of problem. Are they the identical equation? No, they're not. So then it's not IMS. So then it has to be one solution, right? That's going through the list and saying, is it this, is it that, right? If you don't want to do that, then graph it. And once you graph it, you'll immediately know they either cross each other, they don't touch each other, or they're on top of each other, right? If they cross each other, it's 1. If they're parallel, right, they don't touch each other, it's none. And if they're one on top of the other, it's IMS, infinitely many. Okay? So the first one I did by going through a list. The second one, I'll attempt doing it a different way. All right, so there's a first equation. Here's the second equation. I picked this one because this one just looks straight out weird. And I figure a lot of times when people see weird problems, they get scared and they don't try them. So I want you guys to know, like, sometimes if you get a weird looking problem, all you got to do is solve for y. So don't get scared of it. Just solve for y. The other one, I'm just putting them side by side so I can do work for both of them. All right, so I'm just working on them side by side. So if I want to solve for y on the left equation, what I'm going to do is add 3x to both sides first. And this gives me 3x plus 4 equals negative y. Okay, and then to get y by itself, I got to divide everything by negative 1, right? Let's divide everything by negative 1. So I get negative 3x minus 4 equals y. Now, if you don't like the way that looks, go ahead and rewrite it where y is on the left side, and we have negative 3x minus 4. Are we good with that one, just solving for y? By the way, this is a good exercise for the next set of examples because they're going to have you graphing them, and sometimes they'll be already set up for you, no problem. Other times you're going to have to rewrite them like this, and that way you can graph them. Okay? So it's a good practice for you to get ready for graphing. All right, let's do the same to the other side, okay? I noticed there's a 0 on the left, and then everything else is on the right. So I'm going to have to move everything over, right? So let's add 6x. Okay, I like starting with the variables first. So I get 6x equals to negative 4 plus 2y. Okay? And then we'll add 4 to both sides. So I get 6x plus 4 equals 2y. What's my last step to get y by itself? Divide it, right? Divide by 2. So that's 3x plus 2 equals y. Now let me rewrite this so that y is in the front. Y equals 3x plus 2. And I'm going to highlight our equations just so that we know what we're supposed to be paying attention to, okay? This is what I solved for on the left side. This is what I solved for on the right side. What do you think? One solution, no solutions, infinitely many solutions. You think IMS? Hold on, did I do that part? Let me just double check. Yeah, I did do that part. So infinitely many solutions means that they are exactly the same equation. Is that right? No, right? Do they have the same slope? Check. No, they don't. They don't have the same slope, so they're not parallel. So then what am I left with? One solution. That's all I got. It's not infinitely many because they're not the exact same equation. It's not no solution because they're not parallel. The slope is negative 3 and 3. Not the same slope. Therefore, one solution. They will cross. Okay? They will cross. Okay? And again, how do you use Desmos with this? Let me just show you in case you don't remember. It's just desmos.com. Okay? And it's on the paper. One of the equations was negative 3x plus 2. What was one? Negative 3x plus 2 or plus 4? Or minus 4? I think it was minus 4, right? Let me check. Negative 3x minus 4, yeah. And then the other one's 3x plus 2. So 3x plus 2. And look, on Desmos, if you want to know the answer, just click on it. There it is, negative 1, negative 1. Okay? So that's what they mean. Use Desmos if you'd like. It's not cheating, like it's a good skill, but you're not working through your critical thinking if you just go straight to the graphing. Okay? So notice, first thing we checked was, is it parallel or the same, right? We went same and then parallel. And if those fail, then it has to be one, right? One solution. So you want to check to see if the other ones fail first. Okay? Any questions on that part right now? Because that's the first, there's 4 problems like that. I just did 2 of them for you, so you got 2 more to go, but you still got to go through this process, right? And this would be one solution. That would be our answer for this one. One solution. IMS didn't work. Parallel didn't work. Okay, one solution was it. By the way, I'm going slowly through this stuff because even though once you get it, this is really easy. But first you got to get it, right? So I'm not trying to rush through it. That way you can understand it. But yeah, most people find this exercise being easy once they know how to do it, right? Once you learn it. But you first got to learn it. So I don't want to rush through it. But no questions, guys, on part A or part B. And notice, the main difference between A and B is that A was already solved for Y, so you didn't have to do anything, you just had to observe, right? Whereas B, we had to manipulate first. Change everything to Y equals first. And then I was able to make a call about what kind of problem it was. So, all right. Number 7, 8, 9, 10, 11, 12. These are all graphing problems. Like they want you to solve each system by graphing. Use Desmos as needed. Again, they're hoping you don't, but you can if you want to. Okay? But it's always best to try to make sure that you can graph it on your own. Okay? Solve by graphing. So I'm going to give us two equations. We're going to start off with something that's considered on the easier side, and then we'll move on to more difficult. And I don't really think it's difficult because solving and stuff is hard. It's just the more difficult problems are the ones you have to solve for. The easier ones are the ones that are already solved for you. So that's why I call these easier, because I don't have to do anything. I see the equations, and let me just graph them. Okay? So let me go ahead and create a coordinate plane here. So a nice XY axis. I'm going to make it a little big because I don't know how far I have to stretch for these. Okay, so there's my graph, my coordinate plane, I'm sorry, my XY axis. And I want to graph, let's start with y equal to x plus 2. Okay, x plus 2. Let me write these numbers down here just for later. 1, 2, just for reference. So x plus 2 means I start at 2, right? That's where I begin, where my y-intercept is. And then what's the slope for y equal to x plus 2? What's my slope value? 1 over 1, right? So I get to go 1 up, 1 over. Okay? So just so you know, for this problem right here, b was 2, m was 1 over 1. All right? Now let me draw the line. And by the way, guys, when you're drawing these lines, and I can't do it on this screen, but I recommend you use an ID card or something, a ruler, because if your lines aren't straight, sometimes the answers are hard to figure out. All right, just so you know. And it's okay, as long as you're ballpark correct, I'm going to mark you right. But yeah, best to do it with a straight edge. Okay, next one. My B value for this one is -3, and my slope is -1/4. Okay, my B value is -3. My slope is -1/4. So let me go to B value of -3. That's right here on the bottom on the y-axis. And then 1 down, 4 over. 1, 2, 3, 4. Okay, let me see if I can do a good job of drawing a line here. I have a feeling it's going to go right through there. It's supposed to cross right about there. Right here. That's where it's supposed to cross. Okay, what is that value? What is that number? Let's see. 1, 2, 3, 4. So it's -4, -2. So this point right there is -4, -2. This is your answer to that problem. -4, -2. By the way, if you're wondering what exactly are we figuring out, this point where they cross, if you were to plug it into both of those two equations, you would get true statements. So if you plug it into the top one, you would get negative 2 equals negative 2. So that's true. If you plug it into the bottom one, you would get negative 2 equals negative 2 again. True statements, that's what you get. So that's what makes them solutions, because they make both true. All right? Are we okay with this graph right here? A little bit on the easier side, right? We didn't have to solve for anything. It was just kind of going through the process. Let me find one that looks a little bit more on the difficult side. So this one right here looks like it's going to be a little bit more on the difficult side. So here's part B. I'm going to write them side by side already, okay? That way we don't have to rewrite them. So here's the first one, then the other one is negative 16 plus 3x, plus 3x equals 4y. Now remember, when it's not solved for y, it's your job to do that, okay? Your job to solve for y. Right? And this will probably be the last one of these that I do, because all the rest of them are the exact same thing. Either solve for y or don't. It depends on what they give you. Graph it and see where they cross. Okay, they're all the same. So I try to do one that was kind of the easier side. Now we're going to do one that's more on the difficult side. So everything else will be in between. Okay? Nothing more difficult than that one. The one we're doing right now. So to solve the first one, the one on the left for y, what should I move? To the left side? Or you go, which one are you talking about? The left side equation or the right side equation? The left side equation, if I want to solve for y, I want to get everything away from the y side, right? So the negative 16 is already on the other side, so I'm good with that. What else should I move? Yeah, the negative 3x, right? Let's get rid of that part. Because if I move the 16 over, then I'm going to just start crowding the y again, right? I don't want to move things back to it. I want to get things away from it. So, all right, we got 4y equals 3x minus 16. So far, so good. Now what? Remember, I want to get y all by itself. Divide by 4. Okay, so divide by 4. And this is what I get. Y equals 3/4 x minus 4. So far, so good. We got one equation. Okay, we got one equation. I'll graph them after. But let's solve the other one for y. In order to solve the other one for y, what do I do? Divide by 4. Thank you. So divide by 4. So I get negative 4 plus 3/4 x equals y. Let me rewrite this so that y is in the front. Y is equal to 3/4 x minus 4. Now look at those two equations that we just solved for. How many solutions are they going to have? A lot, infinitely many. Why are they going to have a lot? Because they're the same, right? They're the same exact equation. So if they're identical, then they're going to have a lot. What about if this one had like a plus 10? How many would I say? They would be parallel. Good. My slope is 3/4, but they're not identical equations. So that means no solution if that's what it looked like. Because they're parallel lines. Parallel lines do not cross, right? But for us, we got IMS, right? So let me again draw this for you guys just so you can see it. And then we're done. And like I said, they do tell you to use Desmos if you want to. I mean, obviously, Desmos is going to show you the answers a lot quicker. But it really is important for you guys to be able to do this on your own. Don't rely on a machine to do your work for you. That's where we were during the pandemic, and look where it got some of us, right? Some of us are taking. I got a student who came to ask me for help a couple of weeks ago, and they're totally lost in trig. They're having a really hard time, and And I asked them, like, okay, do you remember during the pandemic, were you going through your Math 3 and your Math 2 classes on your own, or were you just using the computer? And I said, be honest with me, I can't kick you back. You know, you're where you're at. You're intrigued, right? And they're like, yeah, I used a lot of computer stuff. I didn't do a lot of stuff on my own. And I said, and that's why the teachers would tell you, don't do that. But we couldn't stop people, right? Because we couldn't do that. There's no way for us to stop people. Um, you kind of have to learn it the hard way, right? You can't just do shortcuts all the time. So anyway, let's go with this here. First equation, 3/4 x minus 4. So minus 4 is down here. And then I got to go 3 up, 4 over. So 1, 2, 3, 4. That's right here. So there's my line. Okay, that's the first one. The second line is identical, which means I just get to use the same point and draw it on top of the other one. So now I got two lines, one on top of the other, which means that your solution is IMS. Okay? Infinitely many solutions. All right? All right, so that's today's lesson.